Criteria. Different CPU scheduling algorithms have different properties, and the choice of a particular algorithm may favor one class of processes over another. In choosing which algorithm to use in a particular situation, we must consider the properties of the various algorithms. Many criteria have been suggested. So, for comparing different scheduling algorithms, there are many criteria, including: first, CPU utilization. We want to keep the CPU as busy as possible. Conceptually, CPU utilization can range from 0 to 100%. In a real system, it should range from 40% to 90%. Throughout, if the CPU is busy executing processes, then work is being done. One measure of work is the number of processes that are completed per time unit, called throughput. For long processes, this rate may be 1 process per hour. For short transactions, it may be 10 processes per second per size. The important criterion is how long it takes to execute that process. The interval from the time of submission of a process to the time of completion is the turnaround time. Turnaround time is the sum of the periods spent waiting to get into memory, waiting in the ready queue, executing on the CPU, and doing I/O. Fourth, waiting time. The CPU scheduling algorithm does not affect the amount of time during which a process executes or does I/O. It affects only the amount of time that a process spends waiting in the ready queue. Waiting time is the sum of the periods spent waiting in the ready queue. Fourth, response time. In an interactive system, turnaround time may not be the best criteria. Often, a process can produce some output fairly early and can continue computing new results while previous results are being output to the user. Thus, another measure is the time for the submission of a request until the first response is produced. This measure, called response time, is the time it takes to start responding, not the time it takes to output the response. The turnaround time is generally limited by the speed of the output device. It is desirable to maximize CPU utilization and throughput, and to minimize turnaround time, waiting time, and response time. In most cases, we optimize the average measure. However, under some circumstances, we prefer to optimize the minimum or maximum values rather than the average. For example, to guarantee that all users get good service, we may want to minimize the maximum response time.